We are now in the second lesson of our chapter 2, limits and continuity. Now let's have the limit theorems. Our objective is to evaluate limits of algebraic function using limit theorems. In the previous lesson, we have seen two different methods of determining limits. That is through observation of graphs and tables of values. But those two methods, as you probably recognize now, have some disadvantages. That's why we need to talk about the limit theorems. Furthermore, the graphical method is quite susceptible to error since graph that is not properly sketched can lead to a wrong limit. On the other hand, computing for several function values, it consumes a lot of time. So, daghay panahon ang atong magugol to complete the table of values. This leads us to pursue more accurate and practical methods of evaluating limits. So in this lesson, we will see fundamental theorems as well as some algebraic techniques that we can use to evaluate limits more precisely. So first, we have the first theorem, 1.2.1. Limit of x as x approaches a is equal to a. And number 2, limit of c as x approaches to a is equal to c, where c is a constant. So therefore, the limit of a constant is the constant itself. And for number 1, the limit of a variable, that is the value of the a. Right? So here, the function given by f of x equals x is the 45-degree line. This is the illustration. Here is the graph. That is the 45-degree line which passes through the origin. As you observe, it passes through the origin, while the function defined by g of x equals c, the constant, is the horizontal line. So yung g of x equals c is the horizontal line with c as the y-intercept. So this is the c, the y-intercept. This is the value of a. Okay? So that is the graphical presentation of f of x equals x, g of x equals c. Now let's add some additional theorem. Theorem 1.2.2. So kaganina, mas klaro, the limit of a variable is equal to the value of a, and the limit of a constant is equal to the constant itself. Now for theorem 1.2.2, suppose that limit of f of x as x approaches a is equal to L, and limit of g of x as x approaches to a is equal to m. So we have the following theorems. We have 4. Number 1, limit of f of x plus minus g of x as x approaches to a is equal to limit of plus minus m. So this is addition and subtraction of f of x and g of x. So the limit of f of x, if it is addition, plus the limit of g of x is m. And pag subtraction side, so L minus M also. Now for the second one, limit of f of x times g of x as x approaches a is equal to L times M. L is the limit of f of x and M is the limit of g of x. So just multiply the limit of two limits or two functions. Now for number 3, limit of k times f of x, where k is what? A constant. So instead of C, here they use the letter K represent as a constant. So the limit of a constant times the f of x as x approaches a is equal to the constant times the limit of f of x. And number 4, the limit of f of x over g of x as x approaches a is equal to the limit of f of x, which is L, divided by the limit of g of x, which is m. Take note that our denominator, which is m, must not be equal to 0. And also, our g of x here must not equal to 0. Kaya pag mag-equal to 0, that is equivalent to undefined. Right? So, those are 4 theorems under 1.2.2. Now, let's apply. So, atong i-apply ang theorem 1.2.1 and 1.2.2. For letter A, we have limit of x as x approaches to a. So according to the first limit, the theorem, that a limit of a variable is equal to a. So the answer here is 1. Why? Because our a is 1. So the answer for letter A, limit of x as x approaches to 1, is 1. Applying theorem, ano yung theorem? Limit here, 1.2.1 number 1. Okay. Next, example number 2. So, limit of x as x approaches to negative 2/3, still, pag variable, the limit is the value of a. So, this is negative 2/3. So, inana lang kasayon, pag variable. For letter C, limit of negative 2 as x approaches to 3. So, negative 2 is a constant. So, according to limit 1.2.1, number 2, that the limit of a constant is a constant itself. So, the answer here is negative. Okay? And also, letter D, limit of 7 as x approaches to 5 over 4. Since this is a constant, so that is also its limit. Okay? This is applying theorem 1.2.1. Now, for E, we have limit of 5 minus 3x as x approaches to 2. So here, we need to apply the second batch of theorems, theorem 1.2.2. So as you observe, this is minus. So what we are going to do is here, atong kaag limit ng kada terms. So limit of 5 as x approaches to minus limit of 3x as x approaches 2. And then we apply theorem 1.2.1 number 2. The limit of a constant is, the constant is 5, so 5 minus limit of 3x as x approaches to 3. So we will apply 1.2.2 theorem number 3. Constant times the function. So k times functions of limit of x as x approaches to 2. So this is 3. And then limit of x as x approaches to equals 5 minus 3. What is limit of x as x approaches to 2? This is theorem 1.2.1 number 1. So if this is a variable, the limit is a. So this is 2. Then simplify 5. 3 times 2, 6. So the answer is negative 1. So that is the limit of 5 minus 3x as x approaches 2. Now for next example, limit of x squared minus 2 all over 5 plus 4x as x approaches to negative 1/2. So as you observe, this limit, we need to apply the quotient. So first, get the limit of the numerator and limit of denominator. So here, you have limit of x squared minus 2 as x approaches negative 1/2 all over limit of 5 plus 4x as x approaches to negative 1/2. So, nanabuhaton una. Then, ato na pong buhagon ang denominator. Ang numerator and denominator nga mga expressions. So, x squared minus 2. So, we can apply now the limit at theorem number 1.2.2.1. So, limit x squared as x approaches negative 1/2 minus limit of 2 as x approaches negative 1/2. All over, also for the denominator, ato pong buhagon. So, limit 5 as x approaches negative 1/2 plus limit of 4x as x approaches negative 1/2. Now solve further. So equals, what is limit of x squared? So limit of x squared, we can use as, diba x squared is x times x. So limit of x as x approaches negative 1/2 tapos times limit of x as x approaches negative 1/2. Now, what is the limit of 2 as x approaches to negative 1/2? So, we all know that the limit of a constant is the constant itself. So, this is 2. All over limit of 5, this is constant. So, 5 plus, so limit of 4x, this is constant times the limit of x. So, 4 limit of x as x approaches negative 1/2. Okay, next, the limit of x. Since this is variable, so the limit is the value of a. So we have negative 1/2. Then the other one also is negative 1/2. And then minus 2 all over 5 plus 4 times negative 1/2. Why is it negative 1/2? Because this is a variable. So the limit of a variable is the a, which is negative 1/2 in the given. So negative 1/2 times negative 1/2, that is positive 1/4. 1 over 4 minus 2. So here we have 5. 4 times negative 1/2, that is negative 2. So plus negative 2. So 1/4 minus 2, we need a LCD, which is 4. So 4 divided by 4, 1 times 1, 1. 4 divided by 1 is 4 times 2, 8. So denominator, 5 plus negative 2, we get 3. So here we have negative 7 over 4 all over 3. And then reciprocal, negative 7 over 4 times 1 over 3. So our limit now is negative 7 over 12. So that is the limit of x squared minus 2 over 5 plus 4x as x approaches negative 1/2. Okay? So just familiarize the different theorems and apply. So another theorem 1.2.3. Take note, if limit of f of x as x approaches a equals L and n is the exponent is a positive integer. Take note ha, positive integer. So it is very important to remember the given conditions. Then the limit of the n power of f of x as x approaches to a is equal to L to the n power. So we have the exponent na. We have theorem 1.2.4. Let p and q be a polynomial functions and cube x must not equal to 0. Kasi pag yung q of x here in the second theorem magiging equal to 0, so it will become undefined. So number 1, limit of p of x as x approaches to a is equal to p of a. Diba? Theorem 1.2.1 number 1, we have x, the limit of x is a p of a. Limit of p of x over cube x as x approaches to a is equal to p of a over q of a, provided that the q of a must not equal to 0. Kasi it will become undefined pag equal to 0 yung denominator. Theorem 1.2.5, suppose that f sub 1 of x as x approaches to a is equal to L sub 1, then limit of f sub 2 of x as x approaches to a is equal to L sub 2, and so on to limit of f subscript n of x as x approaches to a is equal to L subscript n. So we have 3 here. Limit of f sub 1 of x plus minus f sub 2 of x plus minus and so on to plus minus f sub n of x as x approaches to a is equal to L sub 1 plus minus L sub 2 plus minus and so on plus minus L sub n. The second one is limit of f sub 1 of x times f sub 2 of x times and so on f subscript n of x as x approaches to a is equal to L sub 1 times L sub 2 times and so on L sub n. So here, I think this is the same with the previous theorems. It just happens that this is daghan siya. But this is finite since we have the end. Okay? Infinite siya pag and so on lang yung ellipsis lang yung end. And the last one is if limit of f of x as x approaches to a is equal to L and our n for the radical, the index here is an odd integer, then the limit of nth root of f of x as x approaches to a is equal to the nth root of L. So meaning, kinukuha lang yung ng limit ng f of x. Tapos, usa pa siya ikuhaan sa iyang nth root. So let's have some example. Okay? So example, evaluate each limit if exists. So number 1, limit of x squared times square root of x cubed plus 2 as x approaches to. So first, separate lang muna natin yung limit of x squared as x approaches to 4. This is multiplication times the limit of square root of x cubed plus 2 as x approaches 4. And then, ito na siyang naman og solve. So limit of x squared as x approaches to 4. So here, this is x. So we know the limit of a variable is equal to the a. So we get 4 and then squared times. Now this is a nth root. So we need to get the limit of the inside expressions. So what we're going to do, we root of limit of x cubed plus 2 as x approaches to 4. Check. So equals, this is 16, right? 4 squared times square root of, what is the limit of x cubed? So that is 4 cubed. And the limit of 2, since this is constant, so that is 2. So 16 times 4 cubed plus 2. So the answer is 4 cubed is 64 plus 2. 64 plus 2. So 16 times square root of 66. So the final answer now is 16 square root of 66. That is the limit of x squared times the square root of x cubed plus 2 as x approaches to 4. So that's it. Next example. Limit of cube root of x squared plus x minus 1 all over 4 minus 2x as x approaches to negative 2 equals. So we know we need to get the limit na suod sa radical is cube root 5. So limit of x squared plus x minus 1 over 4 minus 2x as ano yun? X approaches to negative 2. Atong solbo ning sud sa radical sign. Okay? So unsaon? Now what is the limit of x squared? So we know this is a variable. So negative 2 raised to the power of 2 plus negative 2 and minus 1, right? Ano di man negative 2 because this is a constant. So minus 1. Then 4 also minus 2 times negative 2. Simplify. Cube root of what is the product of negative 2 squared? That is 4 minus 2 minus 1 over 4 minus negative 4. 2 times negative 2 negative 4 equals cube root of, this is 1, 4 minus 3. And then 4 plus 4 equals cube root of 1 over 8, which is equal to, the cube root of 1/8 is 1. So that is the limit of cube root of x squared plus x minus 1 all over 4 minus 2x as x approaches to negative 2. Sir, why is it? Digidiretso na lang ni mo substitute. Be familiarized with the theorem. Pag variable na siya, automatic substitute lang yung value na a. That's why we have negative 2 here. Then why is it still it is negative 1? Kasi sa theorem 1.2.1, number 2, pag constant, just as is lang na to siya. Okay? Then go on with the process until you arrive the final answer, that is the limit, which is 1/2 for this example. Okay? Next, limit of 4x plus x all over 3 plus 2x as x approaches negative 3/2. So this is very different because if you are going to solve na to ha. So, equals. Siyempre, 4 yan. Tapos, the limit of x is negative 3 over 2 plus negative 3 over 2 over 3 plus 2 times negative 3 over 2. Okay? So, this will become negative 6 plus negative 3 over 2 all over 3 plus negative 3. Okay? So, LCD is 2. right? So here, 2 divided by 1 is 2 times -6, -12, plus -3. Here is 0 na, okay? So if you're going to solve further, we get -15 over 2 all over 0. And this is undefined. That's why the limit of 4x plus x all over 3 plus 2x as x approaches to -3 over 2 is what? Does not exist. Since this is undefined. Okay? Next example. Limit of x squared minus x minus 6 all over x minus 3 as x approaches to 3. So in this example, if you are going to substitute directly the value of 3 in the denominator, the result will be 0 and you can conclude that the limit does not exist. But if you observe the numerator here, you can factor this one. So you get to rewrite limit of x minus 3 times x plus 2 all over x minus 3, x approaches 3. So you can cancel this out because x minus 3 over x minus 3 is 1. So the remaining now is limit of x plus 2 as x approaches to 3. So solve limit of x, we get 3 plus 2. So the limit of x squared minus x minus 6 all over x minus 3 as x approaches to 3 is 5. So, pangitan na to pamaagi na makuha na to ang limit. Kung wala gayud sama sa example ari sa ibabaw, we cannot factor this one. So that is does not exist. Here we can find other ways. We are going to get the limit. Next, limit of square root of x plus 3 minus 2 over x minus 1 as x approaches 1. So what you're going to do here is to rationalize. So equals limit square root of x plus 3 minus 2 over x minus 1 as x approaches to 1. Tapos multiply lang nato na square root of x plus 3 plus 2 over square root of x plus 3 plus 2. So what's the result now? So sa numerator, we have the result of x plus 3 minus 4. Tapos sa denominator is x minus 1 times square root of x plus 3 plus 2 as x approaches 1. Okay? To solve further, yung limit sa itaas, x plus 3 minus 4, x minus 1 times square root of x plus 3 plus 2, x approaches to 1. So, limit x minus 1, 3 minus 4, right? So, x minus 1, tapos square root of x plus 3 plus 2 as x approaches to 1. And then canceled mo. So, limit 1 over square root of x plus 3 plus 2, x approaches 1. So, here, you may substitute now the value. So, this is 1 over square root of 1 plus 3 plus 2. So, 1 over square root of 4 plus 2. So, 1 over 2 plus 2. So, 1 over 4. So that is the limit of square root of x plus 3 minus 2 over x minus 1 as x approaches 1. So you need to rationalize. So in algebra, bawal ang denominator na may square root. So in limit, ato siyang ibalik diri sa ubos para makuha na to ang limit. Rationalize na mo siya pabalik to get the limit. Kasi pag substitute lang nato dayon, so 1 minus 1, 0, undefined. So makaingon ka nga limit does not exist. Pero using rationalization, we can arrive the limit of this one, which is 1/4. Okay? So that's all for limit theorems. So just familiarize the following theorems, do not memorize, and practice and practice.